So let's look at an example. Say we want to calculate the cell potential at a given time at 25 degrees, and we know our zinc plus 2 ions are 0.10 molar, and copper 2 ions are 0.0010 molar, and this is the equation for that cell. So we can look up, again, our values in the table, and the first thing we're going to do, if we're going to use the NERNST equation, is to calculate the standard potential for that particular cell. And here are the values from the table. And why don't you go ahead and calculate that for me? All right, so let's just take 10 more seconds on that. Okay. So let's see if we can get into the 90s pretty soon, because we should be able to do that for this particular one. All right, let's go back to the presentation here. So this was pretty easy. I didn't actually mean for these two things to show up to help you out of what the reaction at the cathode and the anode was. So that was an easier question than I had intended. So first you need to think about, if you're given an equation here, what's happening at the cathode, what's happening at the anode. As it's written, you can look and see, so copper plus 2 is going to copper solid, zinc solid is going to zinc plus 2. And so you can think about which is the cathode reaction, which is the anode, which has a reduction, which has an oxidation going on. And then once you know which couples you're talking about, then you can plug in your values. So at the cathode, we're going from copper plus 2 to copper solid. We put in our standard reduction potential. Using the equation, we have a minus and then the standard reduction potential at the anode. So we have the oxidation from zinc solid to zinc plus 2, and we put in this value and we calculate the number here. So then we have that. We also need to know Q. So why don't you tell me what Q is now? Okay, let's just do 10 more seconds on this. Okay. So here, if we go back, Q is going to be equal to products over reactants, except things that are solids are not changing during the equilibrium, so we leave those out. So it's going to be concentration of zinc plus 2 over the concentration of copper, which gives you a value of 1.0 times 10 to the 2. So just a review of Q. If you need help calculating Qs, we're going to have extra problems for the exam coming up to be posted on Friday. So this will be used in several units. So then you need to know N, and then we have